Hello, students. What's going on? Hope fine. Today I am going to give my last lecture on periodic properties and bonding in elements from chemistry first paper. Today's topic, bonding in elements, contains orbital overlapping, hybridization of orbitals, application of hybridization, and hydrogen bond. Now, our first topics, orbital overlapping. Orbital overlapping are two types, head-to-head or axial overlapping to form sigma bond and sidewise overlapping to form a pi bond. First, sigma bond. Sigma bond can be formed by between two s orbital by head-to-head overlapping. Such an example, we can take hydrogen atom where occur s overlapping. Electronic configuration of hydrogen is 1s1. That means two s orbital when overlap with each other, head-to-head overlap, then they form s overlapping and form a sigma bond. Another process of forming sigma bond between s orbital and p orbital. If we take hydrogen atom, s orbital of hydrogen atom and p orbital of another atom like fluorine, electronic configuration of fluorine 1s2, 2s2, 2px2, 2py2 and 2pz2, 1. Then head-to-head overlapping between s orbital and p orbital form the sp overlapping, and that this overlapping is formed sigma bond. Another process of formation of sigma bond is in between p and p orbital. When two p orbital overlap with each other's head to head, then form another sigma bond. This sigma bond is pp occur by pp overlapping. After the formation of sigma bond, pi bond is formed and by the side to side overlapping. Only two p orbital overlap participate in formation of pi bond. Atomic orbitals. First, what is orbitals? You know, orbitals is area of high probability of finding electrons, right? So S is a orbital and P is another orbital. P is three types, Px, Py and Pz. And D is five types, double dumbbell, pattern of D is double dumbbell, and that is the D, dxy, dyz, dzx, dx square y square and dz square. Another orbital is F orbital, which is 7 types, but your syllabus included only S, P and D. So we discuss about S, P and D. This valence bond theory, that means a very important part of chemistry. By valence bond theory, two orbital is overlapped. According to valence bond theory, unpaired electron of two hydrogen placed in overlapping area. When two orbital overlap with each other, they share their unpaired electron in overlapping area. Another example, methane, ethene and ethine. These are occurred by valence bond hybridization according to valence bond theory. So, what is hybridization? Hybridization means to form a equal energy containing new orbital. When s orbital overlap with p orbital, then they are by hybridization process they form two sp orbital which energy level are same. Although s and p are different, but sp orbital and two sp orbital which energy level are same, such as energy level of sp3. If that is the energy level of sp3, if we take a carbon, electronic configuration is 1s2, then 2s2, 2p2. Outermost shell contain 4 electron. So 2s, energy of 2s is lower, and 2p, we know p are 3 types, 2px, 2py, and 2pz. This 3 type p, so first 2s contain 2 electrons, and p orbital 2p contain 2 electron. Okay. Now 1 electron from 2s rise into or goes to vacant 2pz orbital in excited state of carbon. Okay. Now when 1s orbital overlap with this p orbital, then they form 4sp3, completely new orbital which energy are same. sp3, sp3 and sp3, 4 sp3 orbital. An unpaired electron, 4 unpaired electron of carbon are placed in this 4 sp3 orbital, which sp3 orbitals are degenerate, means same energy containing. 4 unpaired electron are placed in this 4 sp3 orbital, hybridized orbital. These are hybridized orbital, and that is the structure of sp3. sp3, one sp3 hydrogen overlap with hydrogen share its unpaired electron with 4 sp3 of carbon in the compound of methane. Okay, sp3. This sp3, since 1s and p is 3, that means characteristics 25% S character and 75% P character. sp3 structure of methane, where carbon shows sp3 hybridization, where one sp3 overlap with hydrogen, unpaired electron of s orbital of hydrogen, 4 dumbbell or 4 sp3 contain 4 unpaired electron, and this unpaired electron share with 4 unpaired electron of 4 hydrogen. Okay. Next, ethene, where carbon-carbon double bond are present. Each carbon occur sp2 hybridization. In sp2 hybridization, and 1s orbital overlap with 2p orbital, and rest p orbital participate in pi bond, side by side to side overlapping. If we see the energy level of p orbital, energy level of outermost shell of carbon, similarly unpaired electron, 1 electron goes from 2s orbital to 2p orbital, vacant 2p orbital, and they are formed in excited state of carbon, so they are from 4 unpaired electron of carbon. Now after the hybridization, they are from 3 sp2 hybridized orbital. Since 1s overlap with 2p orbital, so 3 sp2 hybridized orbital is formed. And another p orbital is unhybridized. This pz orbital is unhybridized. 2pz, which placed as unhybridized position. So 3 electrons are placed in 3sp2. This 3sp2 are degenerate, but sp is not degenerate. Sorry, rest unhybridized p orbital is not degenerate. Unhybridized electron of one carbon participate in a side-to-side overlapping with another unhybridized electron of another carbon and form pi bond. That is the total structure of ethene, where sp2 hybridization occur and pi bond is formed by side-to-side overlapping. That is the p orbital, unhybridized p orbital, and another unhybridized p orbital of another carbon. They are occur pi bond by side-to-side overlapping. Next example, ethine, where each carbon participate in sp hybridization. That means it has 2 pi bond and 1 sigma bond. Right. That means unhybridized p orbital overlap with another unhybridized p orbital of another carbon. That is the energy level of p orbital. Similarly, in excited state of carbon, one electron rise into 2p vacant 2p orbital and form 4 unpaired electron of carbon. When one s orbital hybridized with another p orbital, then there form 2 sp hybridized orbital. 1s, 2s degenerate sp, 2sp degenerate, 2sp hybridized orbital is formed and 2p orbital become unhybridized. 2p and 2p, these are unhybridized. So, 2 hybridized orbital contain 2 unpaired electron and unhybridized 2p orbital contain another 2 unpaired electron. These are unhybridized p orbital. (2p). One carbon contain this p dumbbell along x-axis contain 1 unpaired electron and along z-axis contain another unpaired electron. Similarly, next carbon is also contain 1 unpaired electron in these 2 unhybridized orbital. Okay, and then p unhybridized p orbital along x-axis participate in side-to-side overlapping with another p orbital of another carbon, and that means p orbital overlap with another p orbital along the axis. So they are formed 2 pi bond. That means this p participate with along the same axis of another p of another carbon, side-to-side overlapping and form 1 pi. This pi orbital is formed by side-to-side overlapping of this 2 p orbital. They form side-to-side overlapping. You can see side-to-side overlapping and form 2 pi orbital. 2 pi orbitals are formed there. Okay. Next example, ammonia, which is also participate in nitrogen of ammonia molecule, also participate in sp3 hybridization. Nitrogen has 4 sp3. Since it participate in sp3 hybridization, electron dominant is 4 and it has one lone pair electron. The electron which are not participate in bond formation, these are called lone pair electron, and it has 3 bond pair electron and its structure becomes trigonal pyramidal. Although sp3 has tetrahedral structure, but in case of ammonia it becomes trigonal pyramidal due to the presence of lone pair. This lone pair is the main responsible for this rotation of or destruction of structure from tetrahedral to trigonal pyramidal. This lone pair electron repulses the bond pair electron and becomes its bond angle 107 degree from 109.4 degree, where sp3 hybridization has 109.4 degree, but in ammonia molecule it is 107 degree. Why? Due to the presence of lone pair electron. Similarly, another example of sp3 hybridization, water molecules, where oxygen is bonded with 2 hydrogen and it has 2 lone pair electron. Its electron dominant is also 4 and it form sp3 hybridization. These 2 lone pair electron repulse the bond pair electron strongly, and that is a 3-dimensional structure of water where 2 lone pair electrons are present, and this lone pair electron repulses the bond pair electron and its bond angle decrease from regular sp3 also, and its structure is also changed. Its structure is bent or V shape. That is the total diagram of sp3 and distorted sp3. Electron dominant is as 4 or in all cases, but lone pair electron, due to the presence of lone pair electron, we can see due to the presence of one lone pair electron, the structure becomes tetrahedral. Okay, it is distorted from tetrahedral into trigonal pyramidal, and due to the presence of 2 lone pair electron, its structure distorted from tetrahedral to band structure. That is another example of sp2. And next topic is hydrogen bond. What is hydrogen bond? Attractive force of hydrogen bond. That is attractive force of hydrogen bond, but it is weaker than ionic bond and covalent bond. Okay, large number of bonds can exert a strong bond. Basically, water molecule contain the hydrogen bond, which is a polar compound. It has 2 poles. Water molecule is share its electron with oxygen, share its electron with hydrogen. For that 10 proton, but 8 from oxygen atom and 1 each from hydrogen. Total 10 electrons. 4 electrons are shared and 6 non-shared electron from oxygen. Okay, for that oxygen is slightly negative. So since oxygen is more electronegative, so electrons are not shared equally in between oxygen and hydrogen. Electrons are slightly attracted by oxygen since it is partially filled. So for that, negative charge oxygen is attract the positive charge hydrogen, and thus they are in liquid form few bond hydrogen bond, in solid form many hydrogen bond, but in steam there is no hydrogen bond since hydrogen bond is weaker than ionic or covalent bond. Hydrogen bond occur when there present oxygen or nitrogen or fluorine. The compound must contain hydrogen and they must contain oxygen, nitrogen and Fluorine. Water molecules are polar. Okay, for that, fat molecules, many fats are non-polar, so fat is not dissolved in water. As an example, if we take water and oil, if we pour some oil, mix some oil with water and shake, but what oil does not mix with water. Why? Oil is non-polar and water is polar. Okay, that is the main concept of hydrogen bond. Why water molecules contain hydrogen